Chromatography is a powerful laboratory technique used to separate mixtures based on their chemical affinities. The word comes from the Greek words for color and writing, as it was originally used to separate colored plant pigments. Today, chromatography is essential in many fields of science, from analyzing blood samples to testing food quality. In this video, we'll explore how chromatography works by understanding the principle of separation by affinity. Chromatography is a technique for separating mixtures based on differential movement of components through a medium. But what does differential movement mean? It means that different substances in a mixture move at different speeds. This happens because each component interacts differently with the materials it passes through. Some components move quickly, while others lag behind, and this difference in speed is what allows us to separate them. Every chromatography system has two essential phases. The stationary phase is a fixed medium that doesn't move. Think of it like the ground beneath your feet. This could be paper, a coated plate, or material packed inside a column. The mobile phase is a solvent that carries components through the system. It flows over or through the stationary phase, much like a river flowing over rocks. The interaction between these two phases is what makes separation possible. Here's the core principle that makes chromatography work. Components with different affinities for the stationary phase move at different rates. Affinity means how much a substance likes to stick to or interact with something else. If a component has a strong affinity for the stationary phase, it will stick to it more and move slowly. If it has a weak affinity, it won't stick much and will move quickly with the mobile phase. This difference in movement is the key to separation. Let's understand this relationship more clearly. High affinity means a component binds strongly to the stationary phase, so it moves slowly through the system. Imagine someone who keeps stopping to look at shop windows while walking down a street. Low affinity means a component binds weakly to the stationary phase, so it moves quickly. This is like someone walking straight ahead without stopping. These different speeds create separation, allowing us to identify and collect individual components from a mixture. There are several common types of chromatography. Paper chromatography uses paper as the stationary phase and relies on capillary action to move the solvent. Thin layer chromatography, or TLC, uses a coated plate instead of paper and gives faster results. Column chromatography involves passing the mixture through a packed column filled with stationary phase material. Gas chromatography, or GC, is specialized for volatile compounds and uses a gas as the mobile phase. Each type has specific applications, depending on what you're trying to separate. The retention factor, abbreviated as RF, is a key measurement in chromatography. It equals the distance moved by a compound divided by the distance moved by the solvent. For example, if the solvent travels 10 centimeters and a compound travels 5 centimeters, the RF value is 0.5. Each compound has a unique RF value under specific conditions, which helps identify unknown substances. Scientists use RF values like fingerprints to determine what chemicals are present in a sample. Chromatography has numerous practical applications across many fields. In biochemistry, it's used for purifying proteins and analyzing DNA samples. Food scientists use it to test for additives and detect contaminants in food products. The pharmaceutical industry relies on chromatography to check drug purity and identify chemical compounds in medications. Forensic scientists use it to analyze evidence and identify unknown substances at crime scenes. From hospitals to research labs, chromatography is an indispensable tool for separation and analysis.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.